Hello everyone, welcome back to the new video. Today we'll be looking into one of the advanced chunking strategies for rack systems. So this strategy explores the possibility of using large language models like ChatGPT and GPT-4 to determine what a chunk should look like. But the underlying idea is to create chunks from large piece of text in the form of coherent topics. So it's not about just creating recursively splitting text using certain delimiter or just segmenting text based on sentence boundaries. We're trying to go a little more logical and create group of sentences and treat them as one chunk where they belong to one coherent topic. So this could be, let's say, about moles as a topic. This could be, let's say, about acids and bases as a topic. And this can be about, let's say, the chemical reactions. So you see, right, what I'm trying to say? I mean, these are three different topics that inherently will have multiple sentences that belong to it. But having a chunk strategy at this level kind of covers the entire spectrum of sentences that talk about the same thing. So it's a little more logical to have this grouping and then use LLMs on top of it to get your answers for a given query in the rack systems. So let's see one of the strategies where we use LLMs to derive these topical chunks. So let's say you have a large piece of text from which you want to do question answering. So a rack system is a good fit for this use case, right? So what you do as a part of this topical chunking is to pick first sentence and give that as topic 1 and create a metadata saying what is the title for this topic, what are the sentences that we have in this, what is the ID for this, and what is the summary of this topic. So you basically maintain this payload for every topic that you create going forward. Then you pick the second sentence and pass it to LLM along with some of the topical metadata such as, let's say, summary, title, and ID. And you prompt your LLM to kind of assign this new sentence to either one of the topic IDs that you have given as a part of prompt or return as none. Because if that's the case, you're going to create another topic over here, right? So let's say model says none. So you go ahead and create topic 2, and this again has all this metadata that you store for this new topic. I guess you're following, right? So then comes the third topic, for which you again pass it to LM along with now metadata for two topics. And you ask the LM to put your sentence in either of these two topics or create a new one. And let's say this time it says it belongs to topic 1. So now you then update your metadata by calling a LLM with two sentences that now belong to topic 1 and ask it to create a new title based on that and append your sentence in this list. The ID will be same and you again generate a new summary based on both the sentences that you have generated. Now a summary is a little more descriptive form of a single line title over here, right? And so on and so forth. You keep repeating this step. And for the final sentence, you again call your LLM with whatever topics you have created till now, the summaries of them, title for them, and the IDs for them, right? Let's say this belongs to a new topic which is TK. So that is a new entry to your topical list that you are already maintaining. So with this, the idea is like you are incrementally adding in a new sentence to every topic as you iterate through the document sentence by sentence, and you're constantly updating the title and the summary based on every new sentence that you add. So that way you're enabling the comparisons going forward being little better because now these are more representative of what a topic 1 represents exactly. So yeah, that was the advanced chunking strategy that I was talking about that takes in a document and creates topical chunks out of it. Now for that question that you were supposed to ask, you create an embedding for this, fire it in a vector database. In the meantime, you already created topical chunks, so you generate their embeddings and index them in the same vector database. With this, you get top k topical chunks, not sentences. Maybe you pick 1, 2, or 3, pass it to LLM along with the question that you had, and you get your final answer. So yeah, that was the technique. Hope this was something new that you didn't already know of. So now one of the questions that can come up, right? Do these need to be sentences? I mean, do I need to make it sentence by sentence? No, obviously not. I mean, you can go about doing any form of chunk that doesn't really spill over to another sentence or paragraph. So it should be self-contained. So for that matter, I chose sentences, but you can go about, let's say, implementing a paper. So there's a paper that proposes what they call as proposition chunking. And they have certain rules to what a proposition looks like. But in the results, they have clearly shown like this to be working better across multiple tasks and multiple data set for the retrieval problem when compared to passage retrievals or sentence-based retrievals. So yeah, so this could be your most granular chunk on which you then iterate and have these clusters created of topics using LLM. So that could again be one of the representation that you can go forward with. So in the next video, I'll talk about what this proposition chunking exactly is. And if you're looking forward to that, make sure to hit the like button for this video and subscribe to the channel so that you don't miss out on the video that comes up next week. In the meantime, if you know someone who is working in the space of Gen AI and LLMs, feel free to share this video and spread the word. I'll meet you in the next one. Bye bye and take care.